Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to right triangle congruency. If you have a right triangle, you automatically know you have a 90-degree angle. So I'm just going to go ahead and draw two right triangles, each with a 90-degree angle. And we're going to talk about how this simplifies, that we get a special theorem that simplifies what information you have to provide. Okay, I'm going to mark the givens. Okay, so those are marked. X, Y, Z, A, B, C. So you might notice that I've marked an angle, 90 degrees, a side, and a side. And I have said in my previous videos that angle side side does not prove congruency. And I will stand by that angle side side does not prove congruency. So why can I say these two triangles are congruent when they're angle side side? Well, let's think about what we've got going on here. X to Z is congruent to A to C, and X to Y is congruent to A to B. And we don't know anything about the third side. And then we also know that the measure of angle Z is congruent to the measure of angle C, and that they're both 90 degrees. That's what's given to us. Okay, so I'm going to write small side letters so that it saves some of our writing. So we have Z, X goes with X, Y goes with lowercase y, capital A goes with lowercase a, capital B goes with lowercase b. Okay, so we learned something a long time ago called the Pythagorean Theorem. We learn it in junior high generally. So our first triangle, that would be x squared plus y squared equals z squared, right? So x squared would equal z squared minus y squared. So x would be z squared minus y squared, and then we'd have to do the square root. So x was really line yz. Lowercase z was really xy, and lowercase y was really xz. Okay, now for the other triangle. A squared plus b squared equals c squared. We're familiar with that one, right? So a squared equals c squared minus b squared. So a is the square root of c squared minus b squared. So a was really bc. C was really AB. And B was really AC. Okay, then we said XY is the same as AB. And XZ is the same as AC. Wait a second, isn't that the same thing as that? So now, because of what I wrote in pencil, we just proved this side is congruent to this side using Pythagorean theorem. And now we no longer have angle side side. Now we have side side side, or side angle side, or whatever you want to use, right? Could we go and solve for angles now if you knew how to do that? Absolutely. So because the hypotenuse and the leg were congruent in the beginning, the other leg had to be congruent by the Pythagorean theorem, meaning that anytime, instead of doing all this algebra, anytime you're given a right triangle and you're given a leg and a hypotenuse, you know those two triangles are congruent by the hypotenuse-leg theorem. And you could write out hypotenuse-leg. You can write it out the whole way, or you can just write HL. So because we've gone through why that works, you never have to go through why it works again. Even though it's an angle side-side, it's a special case of the angle side-side because of that 90-degree angle. So right triangle congruency gives us special cases, and we can do so much more. We can still use side, 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 side angle side. If you want to go through the work, I'm going to choose not to go through the work. So I'm going to draw a shape here, and it's going to look similar to a kite. We have J, K, L, M, and N. And I'm going to have your givens as JK is congruent to KL, and JL is perpendicular to KN. And these are our givens. Okay, so we need to mark this stuff down, and then we need to see what it gives us. We also need to know what we're proving. And I want you to prove triangle JKM is congruent to triangle LKM. So what are we trying to prove? JKM, oh, that's like the left half, is congruent to LKM. Oh, the right half. Okay, we're trying to prove that the left half and the right half are the same. Check. All right, so what have they given us? JK is congruent to KL. Ooh, that's a side, right? JL is perpendicular to KM. Oh, this is a 90-degree angle. Well, that's a 90-degree angle that's not even in my big triangle. Yeah. Okay. I do notice that the two little triangles share side KN. So I can say KN is congruent to KN. I also notice that the big triangle shared side K to M. So I'm also going to write that down. The reflexive property, right? Anytime it helps to have something equal to itself or congruent to itself, you can always write that down. But I need a third side to be able to justify this, or I need an angle to be able to justify this. But let's look at just these little triangles for a second. Because of the 90-degree angle, the little triangles are right triangles. And their hypotenuse is congruent. And we just said a leg was congruent. Hypotenuse and leg. We've already got a hypotenuse-leg theorem. So I can say the two tiny triangles are congruent. Why would I do that? You'll understand in just a second. Sometimes it helps to prove extra stuff to get to the point you're trying to. So we can say triangle JKN is congruent to triangle LKN. And we can say that because of the hypotenuse being congruent and the leg being congruent. And if the triangles are the same, that means when I fold them in half, things will match up, meaning that this angle right here is going to match up to this angle right here. Ooh. And because K is split, we have to have 3 letters to name this. So angle JKN is going to be congruent to angle LKN. Why? Because the corresponding parts of congruent triangles are congruent. Wait a second though. I said this side is congruent. I said this side is congruent. And I said this angle is congruent. What do I have? I have side angle side for the big shape as well, which means I can now state that triangle JKM is indeed congruent to triangle LKM, and that reason is side, angle, side. So mark your information as you go, whether you have to write it on your own piece of paper or maybe you've copied it using a transparency, whatever you need to get that going. But make sure you mark them as you go. Color coding also helps me. Sometimes I mark one in blue, one in yellow, one in green. Once I have all three colors, I know I can move forward. So however it works for your brain, then that's a great way to do it. But otherwise, just make sure you verify that you have your stuff. Right triangles give you the hypotenuse-leg theorem so that you don't have to worry about angle side-side.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.